All right, welcome to day 3. Hopefully by this point you have all of the reasons from your salmon colored sheet memorized. Knowing those is going to make life so much easier for the rest of this unit. If you don't have those memorized yet, you need to take today and keep studying them until you have them all memorized. If you don't do that, you will constantly be playing from behind. You'll be playing catch up the next several months, and the odds of having success is very slim. Okay, you need to take the time and put in the effort to make sure you have those 10 or 11 on the salmon colored sheet memorized. So as part of your work on this Wednesday, if you don't have them all memorized yet, you need to make sure you do that. Homework for day 3 is page 15 and 16. We'll go through the homework ones. There's no warm up. So our given, we have perpendicular lines. So over in our reason, we automatically want to put in our perpendicular lines one. Perpendicular lines implies right angles. Since we're pointing at right angles, we want to state which angle or angles are right angles. Well, if we look, RS and TS are meeting at S. So angle S is right would be our statement. In number 2, we're given an altitude. So we automatically, in our next reason, want to use our altitude reason. Altitude of a triangle implies perpendicular lines. We are pointing at perpendicular lines. So over in your statement in number 2, state which lines are perpendicular. Well, if HN is the altitude to JK, it's just HN is perpendicular to JK. Remember that upside down capital T is your symbol for perpendicular, and you can use it anywhere in proofs instead of writing out the word perpendicular. Well, now in number 2, we have perpendicular lines. So that tells us what our next reason in 3 should be. In 3, we should use our perpendicular lines reason. So we'll do perpendicular lines implies right angles. So we have to state, oops, I have an error there. This is supposed to say and are right. Okay, angle HNJ, so this angle right here, and angle HNK are right. In 3, we're giving a bisector, and it is a segment bisector. So go to your segment bisector reason on your sheet. Segment bisector implies midpoint. So we're pointing at midpoint, so we need to state what is our midpoint and what is it the midpoint of. So if CD is bisecting AB, follow CD, follow AB, okay, they're crossing at D. So D is the midpoint. And unless it's saying they're bisecting each other, it's always the midpoint of the thing that comes second, because the second thing is the one that is being cut in half. So D is the midpoint of AB. Oops, and I missed my little line there on top of AB. Well, because we have midpoint in our next reason, we automatically want to do our midpoint reason. Midpoint implies 2 congruent segments. We're pointing at 2 congruent segments, so state which ones are the congruent segments. If D is right in the middle, that means that AD and BD must be congruent to each other. In 4, we're given midpoint, so automatically for the next reason, we want to do midpoint implies 2 congruent segments. We're pointing at 2 congruent segments, so in your statement, say which are the 2 congruent segments. Well, if M is the midpoint, then we should get GM and MH to be congruent to each other. Remember, with segments, you could write them in either order. So you could have said segment MG and segment HM, and that would have been fine as well. Going on over 5, we have a bisector, but after it comes an angle. So this should be our angle bisector reason, which implies 2 congruent angles. We're pointing at 2 congruent angles, so state which ones are the congruent angles. Well, here's TSR, our angle that's being bisected. There's SP, so the 2 congruent angles should be this one and this one. So the vertex has to be the middle letter. So TSP and RSP are congruent. And you can reverse the order of those, PST and PSR as well. That would be fine. S has to be the middle letter though. Next, we have FH is congruent to GH, and we're in a triangle. Well, that's two congruent sides, so that should imply an isosceles triangle. We're pointing at isosceles triangle, so we need to state which triangle is isosceles. Well, we have triangle GHF is isosceles, and you could have named those letters in any order for the triangle. Well, if we have an isosceles triangle, we have another thing other than congruent sides as a reason. So in reason 3, we'd want to do isosceles triangle implies two congruent base angles. We're pointing at two congruent base angles, so we need to state in our statement which ones are congruent. The base angles are always across from the congruent sides. So here's HG, which was congruent. F is across from it. Here's HF. G is across from it. So that's why we know that G and F are angles that are our base angles. So we're going to be on packet page 10. We're going to be starting to use our reasons to actually prove triangles congruent. To prove two triangles are congruent, remember congruent means that they are exactly the same. You don't necessarily have to prove that every single part is the same in them. We just need to get three specific things are the same, and then the others will just follow suit. So, the different theorems that can prove that triangles are the same. The first one is the side angle side postulate, okay, which we will abbreviate SAS. Now I want you to look at the pictures there, and the thing to notice that will help you recognize side angle side is notice we have two sets of sides marked up. We have our single line sides and we have our double line sides. And then notice it's the angle that's in between them. That's why we call it side angle side, because the angle falls right in between the two sides. If you had something like this, like say that, and then this angle, that's not side angle side because the angle is not in between the sides. The next one is side, side, side. If you have all three sets of corresponding sides congruent, then you will have congruent triangles. So the 1 mark matches with the 1 mark, the 2 with the 2, and the 3 with the 3. Now these statements over on the bottom left here are what's called a congruent statement for the triangles. And we'll be working with those a little bit today. Just one thing I want to point out about a congruent statement in a triangle, the order does matter of the letters. In the first triangle, you just name it however you want. So we named this one GHF. But in the second triangle, you need to make sure it matches up accordingly. So notice G is in between our 1 mark side and our 3 mark side. So the letter that should come first in the second triangle also needs to be in between the 1 mark and the 3 mark. So that was P in this case. Then notice that H was in between the 1 mark and the 2 mark. Well, Q is in between the 1 mark and the 2 mark. That's why that comes next. And then F was between the 2 marks and 3 marks, so that matched with R. So you need the spots to name them so that whatever letters are in first, whatever's in the middle, and whatever's in last correspond appropriately in the picture. Moving over to page 11, another one that we have is the angle side angle postulate. So what this is saying is you have a set of congruent sides that are sitting in between a set of two congruent angles. And then below that, another one we have is angle, angle, side theorem. That's when you have a set of two angles and the side is not in between. So both will give you congruent triangles, but you need to be able to properly identify them by whether the side is either in between the two angles, so that would mean if it's the side connecting the angles, or not in between. And you have congruent statements for each of those, and again, we'll practice making those congruent statements. So those are the four that we have. If you think of your combos of A's and S's, there's two that we left out that don't work. Okay, and I'd like you to write them on the gray boxes there. So the first one that does not work is angle, angle, angle. And the way I want you to remember that that one doesn't work is if your car breaks down, you have to call AAA, and that is bad. So AAA does not work. Another one that does not work is SSA. So side-side angle does not work. And the way to remember that one doesn't work is if you spell it in the reverse way, your mom might yell at you. So that one's bad as well. So what we're going to spend the next portion of the video doing is identifying if the triangles are congruent or not. If they are, we're going to tell why they're congruent and write the congruence statement for it. So what we want to notice here is we have two sets of angles in letter A and one set of sides. The set of sides is not in between the angles. So this gives us angle, angle, side. That is one of our ones that works. So we'll say yes. We've got to tell which triangles are congruent. So you just name the first triangle however you want. So we'll say triangle MLF, or MLB, sorry. Is congruent to triangle. And now we have to be careful how we name the next one. M had one marking on its angle. So that should match with the one that has one marking in the other triangle. So we got to put S first. L came next. That had two markings. So that's got to match with what had two markings in the other triangle. So I, and then the leftover one is A. Then we have to tell our reason. Why are those triangles congruent? Well, the reason they're congruent is either our side, angle, side, 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 angle, side, angle, or angle, angle, side. Well, we have two angles in one side, and the side is not in between the angles. So we would say AAS is congruent to AAS. And what that means is angle, angle, side in the first triangle is congruent to angle, angle, and side in the second triangle. And that proves that our triangles are congruent. If we go to the next one, we only have two things marked. Now there are two of our reasons that we have from our salmon colored sheet that if it is not directly told to you, you can pick them out from a picture, and that's okay to mark them. The two are reflexive property. So if two triangles are sharing a side, eventually we'll see ones that could share an angle as well. Or vertical angles, and that's when you've got your lines that are crisscrossing. If you see either of those in a picture, you are welcome to go ahead and mark them. It doesn't have to be directly told to you in the picture. So we have vertical angles here. We have crisscrossing lines, so we can mark those vertical angles congruent. Well, we have two sides and we have one angle. The angle is not in between the sides. So this means we have side-side angle. Well, that's one of our ones that does not work. So are they congruent? No, they are not. So we're going to practice a bunch more of these. So in the next one, notice we only have two sets of things marked. We have a set of sides and a set of angles. So let's be on the lookout for either vertical angles or reflexive property. There's no crisscrossing lines, there's not vertical angles, but they are sharing RS. So we usually mark reflexive property with an X, and now we have three things. If we look at one of our triangles, we have two sides and an angle in between. When you have two sides and an angle in between, that would be side, angle, side. And that's one of our ones that works. So we can say yes, and we'll name our triangles that are congruent. Name the first one anything you want. By anything, meaning any order. So we have triangle QRS. Well, now angle Q is in between the one mark and the no marks. So that has to match with the one that's in between one marks and no marks in the other one, so T. Angle R had our marking on it, so that matches with the R of the other triangle. And then S is our leftover one. And we said our reason, we had an angle in between two sides, so we're going to have side, angle, side, congruent to side, angle, side. So SAS congruent to SAS. Next one, we only have two things marked, so let's see if we can find one of our two that we can just pick out from the picture. We don't have reflexive property, they're not sharing a side, but we have crisscrossing lines, so we do have vertical angles. 1 mark and 2 marks have already been used, so we'll mark these with 3 marks. Well, what we now have is angle, angle, angle. That's one of our ones that does not work. So this one is a no. We have two sets of things that are the same. We have ones that are 2, we have ones that are 6. But we need to see if we can get a third thing. They are sharing a side, so this does have reflexive properties, so we can put our X on there. So this one would be a yes, because we now have 3 sets of sides congruent, so that's going to be side, side, side. Let's write our triangles first. Name your first triangle any order, so we'll maybe say TBR is congruent to triangle. Angle T was in between the 2 and the 6 side, so that would match with angle S in the other one. B was between the 6 and the reflexive up here, so between 6 and reflexive in the other one will also be B, and then finishes off with R. We said we had 3 sets of corresponding sides, so our reason would be side, side, side is congruent to side, side, side. Going down to F, we have 3 sets of things. We have 2 sides and an angle that is not in between. So that would give us side, side, angle, which is one of our ones that does not work. So that would be a no. In G, we only have 2 things. So be on the lookout. Do we have vertical angles? Well, there's no crisscrossing lines, so no vertical. And they're not sharing anything, so no reflexive. So there's no other things we can get. And without 3 things, we can't possibly get the triangles congruent. So that would be a no. In H, we only have 2 things marked right now. So let's be on the lookout for either vertical or reflexive. They are sharing a side, so that would be the reflexive property. So we can mark that with an X. Well, now, if we look at an individual triangle, we have 2 sets of sides, and we have the angle that's in between. 2 sets of sides, and the angle in between is side, angle, side. That's one of our ones that works. So this is going to be a yes. We'll name our first triangle anything we want. Maybe we'll call it ABC. Well, now we got to get it to match up. So ABC is this triangle. A had the single mark. That's got to match with the single mark in the other triangle, so that's C. So important to note here, even though A is in both triangles, the A in the first triangle doesn't match the A in the other triangle. Well, B is over here. That's in between the 1 mark and the no marks. So that's got to match with D, and then our leftover one is A. We had said we had an angle in between 2 sides, so this would be side angle side is congruent to side angle side. I hopefully looks pretty familiar to the last one. We have an angle in between 2 sides, so this one will work. One triangle we can call AGN. It's congruent to triangle. A was between the 1 mark side and the no mark side. So that should match with R, which is also between the 1 mark and the no marks. G is between the no marks and 2 marks. That should match with T. And then we finish off with W. And we set our reason. We had an angle between 2 sets of sides, so side angle side is congruent to side angle side. In J, we've got 3 things. We've got 2 sides and an angle that is not between. So that would be side, side angle, which is one of our ones that does not work. So no, those ones are not congruent. In K, we've only got 2 things. So we want to be on the lookout for either vertical angles, which are formed by the crisscrossing lines, or reflexive property when they share something. Well, they are sharing side VY, so we can put an X on that. That notates our reflexive property. Well, now if we look at an individual triangle, we have two angles and a side that is not in between. Two angles with a side not between would be angle, angle, side, and that is one of our ones that works. So this would be a yes. So we're going to have triangle. Maybe we'll name the first one ZVY. Well, Z had one marking, so we'll do congruent to triangle, and that would match the one marking in the other one, W. V has two markings, so that should match the two markings in the other one, which also happen to be V, and then Y was the leftover. We said we had two angles with a side not in between, so that's angle, angle, side is congruent to angle, angle, side. So a couple more of these, and then we'll look at some actual proofs. So on page 13, letter L there, we only have two markings. Look for your reflexive or your vertical angles. They're sharing a side, so that's reflexive property. So we'll put a little X on that. In an individual triangle, we have two angles with a side in between. So therefore, that is angle, side, angle. So this is one that works. We'll name our first triangle maybe PMO, which is congruent to triangle. P is the angle that had no marks, so that matches with N. M had the one mark, that matches with M in the other one, and then O is our leftover. And we said we had a side in between two angles, so that's angle, side, angle is congruent to angle, side, angle. In M, we have two markings, so let's be on the lookout for reflexive or vertical. There's no crisscrossing lines, so vertical angles are not present, and they're not sharing anything, so reflexive is not present. We only have two things, so no way to get those congruent. Now the last of this type is kind of a preview of where we'll eventually go with proofs. We do have reflexive here, but still that's only two things. We have an angle marked and a side marked. But these arrowheads, if you remember from several units ago, means parallel. And when you do parallel, you can do your zigzag to get alternate interior angles. So we will eventually learn how we can get those to be congruent. We haven't learned that within our proofs yet, but we will eventually get that. So this becomes a yes because we have two angles and then a side that's not between. So we'll have triangle UST is congruent to triangle. U had one mark, so that starts with R. S was our alternate interior one, so that matches with T, and then that finishes with S. And we have angle, angle, side is congruent to angle, angle, side. So those that may have seemed redundant and a little bit more than necessary to do so many of those over and over again. But the main thing that we'll do in proofs is prove triangles congruent. So being able to recognize which type of congruent statement you have is really important. So if we go down to the bottom of page 13, this is where we kind of start pulling all things together. We're given a couple givens and we want to eventually prove the triangle's congruent. So we always start a proof by just putting our givens in. So let's take a second to write those in. So we'll have our RP congruent to RQ, and our reason will just be given. And we'll have M as the midpoint of PQ. And our reason will just be given. So look at your proof statement. We want to prove two triangles congruent. Based on what we've learned today, we want to pop in your head when you want to prove two triangles congruent that, oh, I need to either get side, angle, side, 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 angle, side, angle, or angle, angle, side. That's the connection we want you to make. Well, let's look at our givens. We are already given that one set of things are congruent, so let's mark that up in our picture. We've got RP congruent to RQ. So we've used our first given. Well, we've got midpoint as our next given. Great. We automatically know what should go as our next reason. If we see we have midpoint, we should automatically do midpoint implies two congruent segments. We're pointing at two congruent segments, so we've got to say which are the two congruent segments. If M is the midpoint of PQ, that would mean that PM is congruent to MQ. We've stated it in our proof, so let's mark it in our picture now. We've used up all of our givens, but we don't have three things yet. So just like we did in the other ones, look for vertical angle or reflexive property. They are sharing RM, so we can do our reflexive property. So we'll write for our reason reflexive property. And our statement is just that Rm is congruent to Rm. Reflexive is just something congruent to itself. And remember, reflexive property and vertical angles do not need to be given to you. You can just pick them out from the picture. Oh, we'll finish off. We now had three sets of sides congruent. So our reason is going to be side, side, side congruent to side, side, side. And our statement will just be what we wanted to prove. Triangle PRM is congruent to triangle QRM. So notice our last line there in 5 is really what we were practicing in the middle portion of this video. Hopefully we got that down really well, so now writing that last statement, the new stuff for today, is not too bad. So one more for this video. We've got a proof, we've got a couple given things, want to prove triangles congruent. So we always start out, just write your givens down. So we have ray CD bisects angle ACB. And we've got AC congruent to BC, with our reason for both of those being given. As we look at our prove, we've got triangles congruent, so we want to be thinking, okay, we should be looking for side, 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 angle, side, angle, or angle, angle, side. We were given one thing congruent in our givens, so let's go ahead and mark those. AC and BC are congruent. Our other given, bisect, and it's talking about an angle. So hopefully we automatically recognize to do our angle bisector reason. So we'll do angle bisector implies two congruent angles. We are pointing at two congruent angles, so we need to state which angles are congruent. Well, here's ACB, and here's CD. So the congruent angles will be those two. So we can call it angle ACD is congruent to angle BCD. C has to be the middle letter. Another option, you could have named those angles like angle 1 and angle 2, and then it's a little bit shorter to write. So that's an option as well. Well, so far we only have two things marked. So again, let's be on the lookout for vertical or reflexive. They're sharing CD, so we can do reflexive property. And we'll have CD congruent to CD for our statement. Well, notice in our picture, in each individual triangle, we have an angle marked between two sides. So our reason is going to be side angle side. And our statement will just be our proof statement there, that triangle ACD is congruent to triangle BCD. And that's it. We've proved that the triangles are congruent. So today's lesson is stuff that we will do dozens of times throughout the next several weeks. That's it for today's video. Have a great rest of your day.